So in this video, I'd like to go over the evaporators, what they are, how they function, and how we use them to cool the cabin air inside of the shuttle. So why call them evaporators? Well, in the last video about the condensers, I described the line going from the condenser to the evaporators called the liquid line. So we know we have liquid going into the evaporator. And in the first video about the compressors, I described how we cannot have liquid going inside of the compressors to be compressed because that would destroy the compressor. Liquids can't be compressed where vapors can be. So it's only vapors that go into the compressor. So we know we have then liquids going into the evaporator and vapors coming out of the evaporator. And that process, that transition thermodynamically from a liquid to a vapor is called evaporation. That's why we call them evaporators. So how exactly do they function to make the air colder inside of the shuttle? Well, as the liquid refrigerant moves from the condenser to the evaporator, it gets to a small aperture. We call it a capillary tube on our evaporators. But it really impedes the process, the momentum of the refrigerant, slows it down. But on the other side of this aperture, the refrigerant has plenty of room. So it has a much lower pressure situation, which makes it much easier for the refrigerant to become a vapor. So about a third of the way, if things are operating properly, about a third of the way through the evaporators, the refrigerant gains heat. And it gains heat through the coils of the evaporator because the evaporator fans are blowing the cabin air past those coils. Those BTUs are being picked up by the refrigerant. So that added heat, along with the lower pressure, causes the liquid refrigerant to become a vapor. And as the refrigerant continues to travel through the evaporator, that vapor continues to rise in temperature. And we call that rise in temperature from the temperature where it became a vapor to the temperature that it exits the evaporator. We call that the superheat value. And that's a metric that we use often to understand how well the evaporators are functioning. A high superheat value is not much better than a really low superheat value. There's a sweet spot somewhere in the middle where the superheat value should be. And we can obtain that by charging the refrigerant level properly and making sure that all of the components get installed properly. Because if anything is not the way it should be, if the refrigerant level isn't as high as it should be or lower than it should be, or a component isn't installed properly, then that will throw off the superheat value. The vapor doesn't take in the BTU amounts that it should be, and so we just don't get the cool air, the heat removed from the cabin air that we should be. So basically this idea of air conditioning, using the evaporators along with the condensers and compressors, is exploiting the second law of thermodynamics. The first law of thermodynamics says, hey, we can't destroy energy, and heat is a form of energy, so we can't just destroy the heat that's inside of the cabin. So we exploit the second law of thermodynamics to overcome the limits of the first law. The second law of thermodynamics says that energy, and again, heat is a form of energy, will basically move from an area of high concentration to an area of low concentration. So with the use of all of the air conditioning components together, we're basically just transferring these buckets full of BTUs from inside of the cabin to the outside of the cabin, trying to deal with the limits of the first law of thermodynamics by exploiting the second law. And that's the way the system works. So what I've got here are the right and left evaporators. They're really very simple units. They're broken into two sections, really. The coil section here and the fan section here. And it's this fan that's sucking air through the coils and blowing it out its mouth that really does the bulk of the work here. So the evaporators are basically made up of a drain pan, and in the case of our evaporators, we do get water that accumulates inside of these drain pans, so they're not something we'll be eliminating like the drain pans associated with the compressors. We do like to remove humidity from the air, and that humidity, as it's been removed from the air, shows up as water in the pans. And there's a drain spout making it possible for the water to drain out of these pans and outside of the car through the floor. The air input side of these things is nothing more than the face of the coils. And what's really most important about the coils is that they really need to stay free of any debris, anything that might impede its progress. It now being COVID-19 season, I've been testing HEPA filters on a few of these evaporators just to see how much the airflow will diminish with this non-porous filter covering the air input side of the evaporators. And what I found is that it only really decreases the airflow by about 6.75%. So that's doable. That's something we can live with. So I believe we will be using HEPA filters on these in the post-COVID-19 world. The air output side of these, again, is nothing more than a fan. The fan is operated off of 120 volts. They use about 5 amps each, so they're pretty hardy fans. There's actually a start capacitor in the electric control box that's dedicated to making sure that these things start and run properly. The fans also operate or blow about 520 CFM, so that's over 1,000 CFM happening in the car at any one given time. So they're really a hardy system, and that's good and bad. They are a little noisy as well. As I was describing earlier in this video, the evaporators have this very narrow opening, this aperture. This is called the capillary tube. Before the refrigerant gets to it, it has to go through this accumulator, and this will sort of eliminate the unit from being flooded by an enormous amount of fluid. So it sort of is a way station for the liquid refrigerant before it goes into the cap tube. We also have the outflow end for the refrigerant and the inflow end. This inflow end is 1/4 inch OD, and this outflow end is 3/4 of an inch. So making the transition when we remove these fittings, as we do on all of the components now, we're brazing our copper piping to the copper piping of each individual unit. And when we do that with this unit, because this pipe is so large, we're having to step down to that 3/8 inch OD copper pipe by way of a 1/2 inch piece of pipe.